Welcome to today's webinar on 8 key components of the database security risk assessment. My name is Phil Ryman. I'm the Director of Business Development at Integrigy, and I'll be the moderator for this e-learning session. The speaker today is Stephen Coast. Steve Coast is the Chief Technology Officer and founder of Integrigy Corporation. He's been working with Oracle products since 1994, and for the past 17 years, Steve has focused on the security and auditing aspects of the Oracle E-Business Suite and the Oracle database, and has written and presented on these topics at various regional and national conferences, including OAUG and the National Collaborative Conferences. I'll now turn it over to Steve.
Thanks so much, Phil. Today we're going to talk about database security risk assessments. And we're going to walk through some of the key components if you are conducting such an assessment against your databases, in particular Oracle databases, because that's what we work with mostly at Integrigy, and that's mostly where we see demand for these types of services. And we're going to walk through 8 key components about what should be included in that. How do you actually conduct one of these security risk assessments? It seems simple. You just go out, look at the database, gather some information. You may be doing a database security scan, things like that. But really, there's much more to it than that. There's many more detailed pieces of information, and how you actually look at the security posture of an Oracle database or a large set of Oracle databases really matters on how in-depth you need to go. What kind of information do you need to gather? How should you be looking at it? What components should you be looking at? Those types of things. Before we dive into the topic, a quick background about Integrigy. Integrigy was founded in 2001 by former Big Six consultants working on large ERP and database projects. We were helping secure databases back then when no one was actually even thinking about the concept. And we actually started doing database security assessments. That was our core focus back in 2001, and we still do that today. So 17 years later, we're still very active doing these types of services. Integrigy focuses both on ERP applications and databases. On the ERP applications, we do a lot of work with Oracle Business Suite and PeopleSoft and a number of other large applications. On the database side, our primary work is done around Oracle, but we also do a large amount of work around Microsoft SQL Server, IBM DB2, Sybase, MySQL, those types of products. We do it 2 ways to help our clients secure their large enterprise applications and databases. We have a series of products, the first being AppSentry, which we'll actually reference in this presentation because we developed AppSentry to help us do our database security assessments. So we developed the product internally first, using it on our database security assessments, and then we actually commercialized it after our clients looked at it and said, hey, we need a tool to help us do this. Our other product is AppDefend, which is an application firewall specific for Oracle Business Suite and PeopleSoft. So if you aren't applying critical patch updates immediately to your PeopleSoft and EBS environments, AppDefend is a solution. It provides virtual patching, additional logging, protection from web security vulnerabilities. It's a very powerful layer of protection for those applications. Where this presentation came from is our services. We're actively working with clients every single day to perform in-depth, comprehensive risk assessments against their large database environments, their ERP environments, finding sensitive data, helping them secure that. We also do a lot of work around compliance. So how do you actually take a database environment, try to make it SOX compliant, PCI, HIPAA. And we also implement a number of security products, things like Oracle Database Vault, Oracle Transparent Data Encryption, Imperva, Guardium. So we're actively working with our clients to help them improve their security posture by implementing different security products. And finally, we're backed up by a world-class research team. Our team at Integrigy is actively finding security vulnerabilities. So a lot of the security vulnerabilities patched by Oracle as part of the critical patch updates are actually found by Integrigy. So we work very actively to how do you actually best secure an Oracle database? How do you best secure the Oracle Business Suite? And we work very closely with Oracle. We're actually an Oracle Gold partner and have a very good relationship with Oracle. So enough about Integrigy. Let's kind of dive into the topic here. And let's start off first by talking about what a database security risk assessment is. Kind of a big phrase there. Very specifically, a risk assessment is looking at the effectiveness of controls. And we start talking about the database security risk assessment. We're talking about the security controls around databases. Are those tools effective? And so the purpose and the output of the assessment is to look at what's the effectiveness of the controls. Is the database secure? Are the controls operating effectively? Are they providing the level of security? The key part of the risk here is, what is the risk of this database? So what's the likelihood it's actually going to be compromised? You're going to lose all the sensitive data in that database. What is that likelihood? Is it probable? Is it highly unlikely because you've got it secured enough? So this is not just looking at some key controls, some configuration of an Oracle database. It's taking the context of the database, and I'll use that phrase a number of times throughout this presentation, is what kind of data is in there? What is the likelihood that it'll actually be compromised? Is someone after that data? How important is that data to your organization? And so therefore, are the controls effective for the amount of data, the risk level of the data in the database, and the possibility that it will be compromised? So that's a very important part of the risk assessment, not that it's just kind of looking at a few configuration, a couple tweaks here and there that you've changed this initialization parameter, you've applied a patch, but overall, what's the likelihood that this database will be compromised based on the current controls and that people may want to attack it or not attack it? So when we talk about this, the compromise of a database, of a data warehouse, is very different than your Oracle Enterprise Manager database. So a database determines, based on how much data it has, the sensitivity level of that data, really drives that risk. And then finally, when we talk about a risk assessment at Integrigy, we're talking about it as also including what are the mitigation steps to improve these security controls? What is wrong during the risk assessment, and how do you actually improve that? It's very important when we do risk assessments that we actually include those recommendations, and how do you actually correct the findings? How do you mitigate these risks in the database? And we do that primarily because a lot of people don't understand this risk around these databases. They don't understand how to fix the problem. DBAs traditionally are not database security experts. Security are not database experts. So you have a gap in the organization between IT security, compliance, which don't have much knowledge around, especially around Oracle databases, and the DBA team, which does not have a lot of knowledge around compliance and IT security. So you really need to come to the table and understand how do you actually improve these security controls and be able to bridge the gap between those two organizations. So there's a few things that database security risk assessment are not. It's really more than a database security scan. We talk to a lot of organizations that, oh yeah, we scan our databases and we have these really nice reports, but is that truly a risk assessment? That's a database security scan. You're checking the configuration, you're checking some low-level details around the database. There may be some initialization parameters. Are you applying patches? Are there some default passwords? Those types of things. And there's some very good tools out there that do that. So like the Oracle Database Security Assessment tool, DBSAT, is a tool that does that. It provides you that base scan, but it's not a security risk assessment. It's not going through the entire database to make sure that the controls around the database to secure the data, to make sure that it's operating effectively and securely are in place. That's just telling you some tweaks. Is the configuration okay? Are you meeting the configuration standard within the organization? It can definitely do that, but it's not doing more. Another area is some people do what they call a security risk assessment, and they're really just trying to do a product recommendation. They're just doing this to say, okay, yeah, you need to go buy Database Vault. You need to go buy our nifty silver bullet database security product, which doesn't exist, but hey, we can solve all your problems. A security risk assessment is really looking at beyond what you can do with security products. Because again, database security is a many different things. It's policies, it's operational procedures, it's privilege assignments, it's database designs, things that security products can handle pieces of this, but they don't handle the entire aspect of a database environment. They don't make sure it's secure. The controls are effective from top to bottom, from left to right. And that's a part of the security risk assessment, is you're looking at all these different things working together to make sure that the data is secure, that's not going to be stolen, it's not going to be compromised. And then finally, as I mentioned before, the context matters here. The context of the database really matters. It's what's in the database that matters, because that's what somebody's after. You're securing the data, and therefore you're going to secure the database because you want to keep that data private. You want to make sure it's well controlled, that someone's not either stealing it, confidentiality part, they're not changing it, so the integrity of the data, or the availability of the data, that someone's shutting down your database so that therefore your manufacturing line is down, or your key database is down that no one can access, and therefore part of your business is down. So you're making sure that all those pieces in terms of confidentiality, integrity, and availability are in place for that data, and that matters based on what data is there. some databases within your organization, if it was down for a week, probably nobody would notice. Others, if it's down for more than a minute, your business could potentially stop. So really the context matters here. When you're doing the risk assessment, that is part of the risk assessment, is to determine what is the importance of this data, what is the importance to the organization, and if I lose the data, if the data is compromised and changed, if it's not available, how does that impact the organization? And this really matters also on who accesses the data. So in some databases, I may have no ad hoc users. Other databases, I may have thousands of ad hoc users, and that matters on the security risk assessment also, in terms of how much access is to the data, how important is this data, and things like that. So as you do go through a security risk assessment, some databases are really easy. Some are super complex. So when we do like a large data warehouse, it may take us a month to do this risk assessment against a large data warehouse, or against a simple little web application database that's not providing much value to the overall organization. We can potentially do that in 2 or 3 hours and do a really good job in 2 or 3 hours, versus a data warehouse where even after a month, we may not be sure, because there's so many data feeds, there's so many users, there's so much access, there's so many privileges, that unless you go through each of those, you're not guaranteed at the end of the day that you've actually addressed every operational risk to that database. So what are some of the issues here when you're actually talking about database security? What are some of the things that make the security risk assessment difficult to do? And one of the key ones is when we talk about a database, we're really talking about an application also. Databases don't exist on their own. Very seldom is there ever a database that just kind of contains data and nothing else happens with it. It's really the database is there to support an application, to store the data, to make sure it's secure. Therefore, the application is really driving how that database is used. It's the data model, the privileges. And in some cases, your application may not allow you to actually patch a database, may not allow you to upgrade a database. In some cases, the application vendor may have gone out of business and is not certifying new versions of the database. So you may have an older database version that therefore now the vendor is not providing security patches around, and you have to do a security risk assessment around that, which an obvious answer is, oh yeah, upgrade the database. Unless you get rid of the application, you can't upgrade the database. So there's lots of issues that may complicate the security risk assessment that you have to look at. How do we actually address that it's not patched, it's an older database version? There are some inherent security risks in that version. The database or the application vendor may have come up with some very stupid data model that they require every account to have DBA privileges. Again, we've seen it. That exists. Most often it's around just the application account that requires DBA privileges, which is not the best idea. That increases risk. And oh, by the way, in order to manage the application, a DBA has to use that account also. So therefore, not only is the application accessing that account, I have ad hoc users accessing that account. It's a generic account. So there's lots of different aspects here that the application can cause many, many issues in terms of especially security that then you have to address as part of the risk assessment. Is that a problem? Is that providing additional risk in this environment? Is that actually negating many of my other preventative controls? Is it then causing my detective controls to produce too much data, which then becomes a problem on the effectiveness of those controls? So again, there's lots of things that can throw a database security assessment off, that now I have to address issues that typically I wouldn't in one database that's well managed. Another database has a poorer application, that becomes very difficult. Again, the application architecture really can complicate this, because again, application developers they do what they do. They write code. They are not data architects and DBAs, and a lot of times, especially in custom application development, many organizations don't have data architects. The DBAs are looking to make sure that, yeah, this thing can perform, but they're not getting to the low level of detail that you may need to do on a large application to make sure that it's secure from a database perspective. Finally, the business requirements sometimes tell you what you can do and not do with a database. And so most organizations, if you do a database inventory, you'll actually see you have a lot of older versions of databases. Those may not be supported by the vendor anymore. In terms of Oracle, unless you've upgraded the database in the last 18 months, Oracle is very stringent about what security patches you can apply. So if your database is typically more than 18 months old, you cannot apply security patches. Therefore, you have open vulnerabilities. Therefore, if anyone can connect to the database with an ad hoc database account, they can potentially compromise the entire database. Therefore, all your other security controls that you put in place, that you're making sure that this database is secure, it's meeting a configuration standard, but now I've got a massive risk in terms of just one person who can connect to the database can compromise the entire database because, oh, by the way, it's an old version, I don't have security patches, therefore the database can be compromised. So these are the things that need to be accounted for in the risk assessment. Not only, oh yeah, okay, you've got a good configuration, no one's got really bad privileges, but again, it's the lowest hanging fruit, the little piece, that one thing that you missed or that one thing that you can't control that can circumvent other controls. That's how the database is compromised. And that's where the risk assessment is looking is, okay, where's the risk? Where do I need to focus my energy and effort on this particular database or in my entire Oracle database environment? So there's two concepts that we like to really bring up during a database security risk assessment. And one is the concept of snowflakes. Databases are snowflakes. They are all different. This is very different in an IT organization when you especially compare it to servers and desktops. A lot of people kind of take servers, desktops, databases kind of fit into that model in their mind that, hey, they're kind of all alike. It's just now another service running. The problem with databases is that everyone is installed one by one. So every time I pop up a new application, I install the database. That database is then, typically what happens is you open a ticket, the DBA gets a ticket, oh, I need to go create a new database. They go create the database. It'll be most likely whatever is the latest version supported by the vendor. I'll try to put in our standard configuration. Then I'll have to read the application documentation from the vendor. I may have to make some changes. So a lot of the things that are happening in that database are driven by the application. And so I may have 1,000 applications with 1,000 databases. Therefore, the database configuration may be similar in certain regards, but it very quickly deviates from one another. So therefore, they are different enough from each other, where in the server and desktop world, very seldom do I have a wide variation between desktops. When I go out and I had Windows 7, the organization went out and said, we're going to deploy Windows 10, and we have a gold copy of Windows 10, and we're going to blast out Windows 10 to our 1,000 desktops. And they pretty much look alike. There may be a little bit of variation, but there's very little, where in databases, there is significant variation. At one time, I may be saying, okay, yep, all our databases right now are Oracle 12c, here's our standard configuration. But the Oracle databases will deviate very quickly from the standard configuration, that they look differently, the application accounts are different, the privileges are different, how they're accessed is different. Configuration changes may be made per database that this database can't support that one of our configuration standards. Now we have an exception. So they become very different very quickly. Therefore, when you actually do a database security risk assessment, it's very hard to make extrapolation saying, hey, I looked at one database, therefore this is what's going to be good or bad in every other database. No, you have to go much farther than that, spend a lot of time looking at individual databases, especially your most important ones, because you cannot assume that they're all alike, they're all secured the same way, because there is so much variation between them. The other concept is databases tend to be evolutionary. They tend not to be, I do it all at one time, where like on desktops, I roll out 10,000 desktops at the same time. I keep the configuration and check very well. I may have a couple of waves of that, so I may have 5,000 desktops that look alike out of my 10,000, things like that. Databases tend to be one by one, and they live for a long time. So it's not unheard of to have a database. It may be running the latest version, but it's been around for 20 years, so it's been upgraded over a period of time. So it's got a lot of history in there. It's got a lot of different database accounts. It's got a lot of privileges. And again, the application is heavily influencing which applications I can upgrade. So in many cases, an organization says, hey, Oracle 19c has come out. We're going to now support 19c. We're going to start upgrading all our databases. The organization may get 60, 70% of their databases upgraded to 19c. Unfortunately, a subset can't be upgraded. And then we do it again, and the subset can't be upgraded. So then I've got these actually, what you could call subgroups almost, based on versions. Also, I might have acquisitions in the environment. So I may have actually acquired another company that then we brought in 100 databases from them. Those databases were configured at a different time. And we even see in cases where these subgroups of databases where you can kind of say, well, they look alike, they're similar in nature for some reason. based on version, patch levels, how they were configured at one point. We've actually even seen that change based on DBA managers. So the overall DBA manager may have been very strict in one case, and he was very rigorous on how they did configuration. So therefore, most of the databases meet that. That person may have left the organization and somebody who's not as rigorous has come in, or there may have been some other turnover in the organization in terms of DBAs, and therefore things are a little bit looser now. So you can actually see different aspects when you actually, especially when you look at across a large number of databases. If you look at 50 or 100 databases, in some cases we do 1,000 databases, you look at it and say, wow, this, you can tell these subgroups within were based on different reasons. And again, those are all different within the subgroup, but you can kind of pull out that, hey, these were upgraded at one point, these were very rigorously installed and actually a little bit better, so we have a little bit more confidence in them by just looking at them, things like that. So again, database security is very dynamic across the organization for a number of reasons, and each database is just very different and very unique. So when you do an assessment, don't ever assume that, hey, I looked at database A, database B is probably going to be the same way. There'll be very many similarities between the two, most likely in an organization, but there will also be enough, maybe 20, 30% of your findings will be very different across databases. And in some cases, 50 to 80% in some of the assessments that we do. Another concept around database security that requires you to constantly be doing database security risk assessments, so you should be doing it periodically, you should be doing this potentially every year within an organization, is what is decay. Database security decays over time. And so what happens typically on a database is, well, we need a new application, so the DBA goes and does the install. He actually goes through and installs the application. The application says, oh, tweak this, turn this off, turn that on, give these excessive privileges to this user. Hopefully before go live, the DBA actually does some hardening. Okay, we're ready to go live. Let's actually harden this down, actually go through our configuration standard and make sure we're fine. Then we're applying security patches over time. Unfortunately, we may not be able to do an application upgrade right now, so therefore the database version may be obsolete, so there may be actually open exploits in the environment. We may add a bunch of new customizations, we may add in new interfaces. So over time, it decays. So some organizations, hey, when we went live, we did an assessment of this database. It looked great, everything was perfect. 3 years later, well, you should potentially be doing an assessment then also, because over time, lots of things are happening in this databases, more users are being added, problems are rising in the database, that database version may be obsolete, things like that come in over time, and therefore you need to be constantly reviewing your security posture on your databases for all the databases. Where are my problems? Which ones have sensitive data? Which ones do I need to spend more time on worrying about than others? Because again, security is just not static. It's decaying over time, just based on either time or what's happening in the database. Another issue that drives database security is really connectivity. And this is the complex problem, especially around large databases. When you have a data warehouse, you may have 1,000 different connections a day from different places, different locations, ad hoc users, interfaces, the DBAs are coming in. You may have reporting tools, you've got management tools, you've got the data warehouse administrators connecting and doing things. Therefore, you always have to be aware of that there's lots going on, there's lots of connectivity, and any one of these points that's compromised basically compromises the entire database potentially, depending on how privileges are set up, how our users are set up, what's the security configuration of the database. So it's not just, hey, there's one little application connecting and there's one DBA maybe managing it. In large databases, there tends to be many, many different types of connections. And each of these types of connections are unique, and how you manage them, how you actually secure them, how you make sure that they're valid is very important. So we actually will show you at the end of this presentation some matrices that we go through to talk about how do you actually address this problem. Because it's not, the way I address DBAs is not how I'm going to address ad hoc users. The way I control the application account is not how I control ad hoc users. So therefore, the type of user connecting matters a lot on what they can see and how I secure them, how I make sure they're audited, how I make sure that that account is well controlled. So now let's kind of get into the action assessment. So here we'll walk through all the different phases, all the different steps of actually performing a local database security risk assessment. In the upper right-hand corner, you'll actually see some numbers. Those are actually now the key components. That's instead of kind of just laying out 1 through 8, what we did was just kind of walk through the process, walk through all the different steps required, and I've actually labeled the 8 key components. So the first thing you have to decide is when you're performing your database security risk assessment is, what is my scope? What am I going to look at as part of this? And there's a couple of different ways you can do this. And as part of Integrigy security assessments, we do these projects all the time, and we actually do all 3 of these. Sometimes we'll look at a single database. So this is maybe the data warehouse. And typically this is one of the more critical databases in the organization. You need it in-depth. It may be a brand new application going live. So we actually just finished a security assessment that they have a brand new application going live. They really wanted to look at what's important in this one database and do a very in-depth review of that. In other cases, it's a large data warehouse that's been around for 5 years and they want that looked at. So that's really the simplest form of a security risk assessment, is looking at a single database, because again, you can be very focused. You can go very in-depth and spend a lot of time looking at every single privilege. You can do database security scans very easily against a single database. You can do sensitive data scans against that database very easily. The problem with a single database is a lot of organizations that ask, hey, how are all our databases? You looked at that one, give us an assessment of how all our databases are working. And unfortunately, when you do a single database review, it's very hard to extrapolate those findings based on, again, these are snowflakes. You're not quite sure that this database may have had a little bit more focus, it may have been secured, or this database was just wildly insecure based on the application and a poor management by a DBA. Where our typical project is much more around database sampling. So the organization wants to look at how security is working for the databases in the organization. So you'll sample and look at the critical databases. A lot of times we call this a top 10 project. And we're looking at the top 10 databases in the organization, and maybe 25. But some number is picked and say, okay, let's go look at a set of databases, and then we can try to extrapolate those results out so we can understand the security posture. We can identify some of the enterprise-wide security controls that may be missing because, again, we've looked at enough databases. So therefore, now we're sampling across the databases. And the sampling here is very critical because, again, there's silos of either DBAs potentially, of platforms, versions, compliance, sensitive data. So when we look at a sampling of databases, we tend to want to look at the critical databases. We want to look at it by database platform. A lot of what we will do is first look at like the key database platform, that may be Oracle, and then do other databases, because at a typical large Fortune 1000 company, that's kind of where we typically do our security assessments, you'll see maybe 50 to 70% of the databases are Oracle, a large percentage, maybe 20 to 40% are SQL Server, and then you'll have a smattering of IBM, DB2, Sybase, Teradata, Informix, MySQL, other databases. But traditionally for mission critical databases, people are typically using Oracle within the organization. And then we'll sample based on version. So let's say we're looking at just the Oracle databases, we'll want to make sure that we're looking at 19C, 12C, 10G, and potentially there may be some 9I databases in the organization, and we'll want to look at those also. We'll potentially go across compliance, so that there may be SOX databases, so maybe GDPR, which is the European privacy regulation. There may be PCI, which is for credit cards. We'll also try to look at maybe by sensitive data elements, if the organization has that information. So typically, most organizations don't keep a sensitive data inventory. So one of the questions you should ask within your organization is, go to your DBAs and say, okay, tell me every database that has credit card numbers in it. Tell me every database that has social security numbers in it. Tell me every database that has the British health identification number in it. Very seldom is that information maintained because, again, that's the sensitive data. That's typically, if I'm going to lose that data, that's going to cause the most pain to the organization. And finally, there may be DBA silos. So within the organization, there may be multiple DBA teams. So typically, it's around database platforms. So there may be an Oracle database team. There may be a SQL Server database team. Those database teams tend to operate very differently. So if you look at Oracle databases, and then you look at SQL Server databases, the security may be wildly different, where the Oracle databases are very well managed, but the SQL Server databases are just a wild west, and there wasn't any security controls thought through it. So it's very important to understand that. Or there may be two separate DBA groups that manage Oracle databases. That happens in many large organizations. And so as part of the database sampling, again, you're now starting to review more of the enterprise-wide security controls, processes, and procedures if they exist. And then we can potentially extrapolate from that sampling outbound. The final type of assessment and scope is the largest, where it's all databases. So some organizations say, yes, we need to have at least a confidence in all our databases. And now the problem is, how do you actually perform this for 100 or 1,000 databases? How do you do this in a very large environment? And so typically what we'll do is actually spend much more time around the enterprise-wide database security controls. How are they managing these databases at a very large swath in terms of how are you doing access management? How are you doing auditing? Is there encryption standards across all databases? Is there a database security standard across, and how is that implemented? And then we'll potentially sample some of the critical databases, at least get a much more in-depth understanding of a small set of databases, but then hopefully we can do a scan across all databases. So the idea is to then scan every database against the database security configuration standard to make sure that all databases are secured to the same standard. What we like to do is actually have that scanning set up ahead of time, and that should be its own separate project. So before we actually do some of this work, we'd actually like you to implement that across the organization and actually get all databases on board, start scanning them, and then start doing a more of a risk assessment. Then you can go in depth and find out, okay, this is where we have problems. Let's implement that in the scanning and now push out a more rigorous database security standard based on some of the problems that we've seen in some of the databases that were sampled as part of the risk assessment. So again, none of these answers are wrong. It's just based on how you want to approach it. What are you looking to accomplish in the organization? Are you thinking about database security at an enterprise-wide, or are you only concerned maybe about the data warehouse? Is really what drives the scope here. Another piece of the scope here is around test and development. Do you include test and development in the scope of a database security risk assessment? Some people say absolutely not, because we're only concerned about where our sensitive data is. Other people say, well, that's part of our sensitive data may be in some of those. And this is a broad oversimplification of the issue. But traditionally, if you look at databases within an organization, especially around Oracle databases, you tend to have two models. One is like custom applications. These are especially the ones developed in-house, that I have a true development test production environment. And I don't have production data in test and development. So typically I have some sort of test data that's getting loaded in development and test. I'm doing migrations from test to production, and really all my data is in production. That's really where I'm worried about performing my risk assessment, because that's where the data is. That's if someone compromises the data or if someone changes the data, that's really where I have the risk around this. I do have some risk in terms of migration, that someone's not breaking into the development database and changing the code before it's migrated to production. So there's some issues there I probably need to address as part of the risk assessment, but I'm not actually doing in-depth evaluations of development and test databases, because again, if those are compromised, if someone's in there changing data, except for code being migrated, I don't have much of an issue. Package applications, especially applications like Oracle Business Suite and PeopleSoft, are very different, because I've got my production data, I've got things in production, I've got the sensitive data, and what happens is I'm actually potentially doing clones or copies from production down to test and development. And so in a very typical Oracle Business Suite environment, I may be doing that cloning process on a weekly basis, and some organizations do it daily. So I'm taking a full copy of production and copying it down to test, because these applications are so large and so complex, I can't create that test data that's needed. So I really have to have something that's mirroring production, and I'm copying my sensitive data. In this case, the red boxes here are PII, which is personally identifiable information. So think about that as potentially somebody's social security numbers along with their date of birth and their name and address and things like that. I'm copying this data down, and now my development and test environments are mirroring my production. They have the same amount of data, although the security controls around those databases probably are a lot less. I've opened up to developers. I mean, in some cases, a lot of developers change the key passwords to the application to something that they can remember, because they have to share it around to all the developers. So I have full access by my development team to potentially all my sensitive data. So now this becomes very much more problematic. And so now during the risk assessment, what am I looking at? What do I care about? Am I looking at development and test also? Is that as part of my production? I may be looking at what they're actually scrambling. So some organizations will take that sensitive data and test and actually do what they call scrambling, is actually change the social security number so they're not readable. I keep the vast majority of the data, which I don't consider sensitive. There's no risk of someone changing it. It's much more at this point if someone's stealing the data. So there's lots of different issues. So you need to evaluate, do I need to look at test and development? Is it an issue? However, even if you're saying, oh, no, the development team has guaranteed me that there's no sensitive data in production or test, or in development or test. However, we find in many cases, we'll actually do sometimes a evaluation. We'll do a sensitive data scan against development and test. We'll actually find production data, because what happened was that developer that one time, or that one developer says, oh, I always need production data. I can't handle this non-production data. It's scrambled and it just doesn't make sense, and I really need production data. So they'll actually do production data loads in the test and development against policy, against standards. And so how are you going to ever catch that? How are you ever going to address that you may have all your employees' social security numbers in your test environment? It happens all the time. So again, even though they say it's not happening, do you need to actually evaluate test and development in certain cases? And the answer may be sometimes yes. So when we talk about a database security risk assessment, it's actually a fairly simple process. This is not an overly complicated process overall. It's how you actually execute the process is very important. So when we do a database security risk assessment, we have 4 basic phases. The first phase is we're looking at the organization's policies, standards, and procedures around database security. So we're actually asking for them for a large set of documents to actually review how do they think it should be working. And this is the key, is how do they think it should be working? How have they documented the process that it should be working? And then we go to phase 2 and we actually do some stakeholder interviews. So we talk to different teams within the organization to say, okay, we've read the policies and documents and we understand the process as it should be working. How do you actually think it's working? Where do you see the risks in it? What works, what doesn't work? Many times there's gaps in the policies, things that aren't included. So an organization may not have an encryption standard. So how does actually encryption work on different databases? Is it database by database? Have you bought a product? How does that work? Phase 3 is then we actually do the scan. So we're actually going and connecting to the database and pulling back a large set of information, comparing it to security baselines, but also gathering information about privileges and things like that. And then the final point is that phase 4 is the final true risk assessment. This is the analysis and review. So someone's actually taking the data. And again, a security scan is not a risk assessment. A security scan can give you a very nice report and say, this is wrong and this is right. But it really can't review how are you doing backups? Are you doing it correctly? Are the backups secure? Are the backups going to an off-site location? How are you actually assigning privileges? How are you terminating users on a regular basis? A scan is very good at saying, okay, this parameter is wrong. This user has a default password. It doesn't tell you that the DBAs are just going in and creating users based on an email from the user themselves to give them DBA privileges. A scan doesn't tell you that piece of information. That's why the security risk assessment really requires the hands-on, going through the detail, going through the information to make sure how do these processes actually work? Does it meet standards within the organization? Are there gaps and weaknesses within that process? And these 4 phases overlap, and there's a little bit of reason for the overlap because again, first phase, you want to gather the information, and you need that information before you actually conduct some of the interviews. And then you also actually may want to scan some of the databases before you actually talk to some people like the application owners, DBAs for some of these applications, because you want to get the data. You want to understand, okay, what's this doing? And then you want to actually be able to reference the data from the scan in the interviews. And then finally, the scanning can sometimes take longer, especially if you're doing a large number of databases. So therefore, we may actually start our write-up and our analysis of policies and procedures based on the interviews and a few databases before the scanning is actually completed, just as trying to keep the overall timeline fairly short as much as possible. Because again, most organizations want the assessment done as quickly as possible so they can understand what their security posture is, if there's actually weaknesses in the environment. So when we talk about policy, standards, and procedures, this is a very wide swath of information to gather up. Again, the policies are organizational level policies in terms of security standards. What's the password length in the organization? Is auditing required? Is encryption required for sensitive data? What is the sensitive data protection? What's the sensitive data policies in terms of elements? So is it social security number? Is it name, address? Is it date of birth? What does the organization look at in terms of critical sensitive data and how must it be protected? Who can access that data? What's the backup recovery requirements? What's the encryption requirements? Things like that. Per database, is there SOX, GDPR, HIPAA, California privacy requirements in the organization? And then the next layer is actually database-specific standards. So for like Oracle databases, how is the configuration? Is there an Oracle database secure configuration standard within the organization? How is actually auditing done? Is there an auditing standard? Is there a vulnerability management standard that, hey, this is how you actually apply Oracle critical patch updates? This is how you do Oracle development in terms of PL SQL packages. Here's our development standard saying that there's no dynamic SQL allowed because it's vulnerable to SQL injection. How is all that done? And then finally, it's the procedures. How are we actually, what's the procedure for doing a database installation? Is there one? For database cloning, for database monitoring? How is Oracle database change control done? How are those migrations done? How does access management work? Who actually creates the account? Who approves the account? Who actually approves privilege assignments? How is sensitive data scrambling done? So again, a lot of information. And again, some of this may exist, some of it may not exist, some of it may be specific to databases, some of it may not be. So like the password standards for the organization, where like the password length is 8 and it's complex and things like that, may be enterprise-wide and there's nothing ever documented for databases. Is that a gap? How is that actually implemented in the databases? Because again, we're going to scan and find out, did they actually implement password security standards using Oracle database profiles, things like that? How is that implemented? Is there a standard for that in the organization? And the goal of the security risk assessment is always to try to base it off of something at the end of the day. So if I say, well, the password lengths are not controlled around 8 or higher, is that the organization for the standard? I'd rather not make up and say your password length should be at least 7. I'd rather say the organization standard is 8, therefore it should be implemented as 8 in the databases, and it's not implemented as 8, therefore that's an issue. Versus saying, hey, 7, that's good enough, but the organization standard is 8. So we always want to base it off of going back to what their actual policies are, what the standards in the organization are as much as possible, and identify gaps where there are things aren't in the standards, aren't in the policies. Potentially, we identify sometimes within the IT security policies that there's gaps that it just doesn't work for databases very well. Therefore, the database team isn't doing anything. Therefore, you should be updating the IT security controls in the organization to say, hey, there is this exception, or we can just broaden it slightly to say, yes, for databases, this is what you should be doing. Therefore, then it works and the DBAs can understand how to implement that within the databases. And the goal here is always to try to map back to something. And again, an organization should have a database security program. Only the largest organizations in the world do. Large banks tend to, but most other organizations don't have a database security program. It's kind of a set of loosely aligned standards. The DBAs may be doing it, may not be doing it. But again, for a comprehensive database security program, all this works together. So when we're talking about a database inventory, our database inventory is feeding into things like our database scanning for configurations. Our configuration standards are flowing into how we actually do some of our auditing. Do we have database auditing enabled? How we're actually doing database protection and those types of things. So at the end of the day, most organizations won't have a database security program in place, but if you're trying to meet some of these things into a database security program, you can do that and try to figure out where are the risks, what's missing, what should be implemented, and a database security program, at least from a template perspective, provides you a very good basis for that. The next aspect is actually doing database security reviews and interviews with the key stakeholders. So looking at the DBA team, especially the DBA manager, that's kind of a key person because they're kind of really driving, especially in terms of the different silos like Oracle Database, SQL Server. They're really providing how secure the environment is. Are they pushing it? Are they have a focus in on it? And then potentially even interviewing senior and lead DBAs because those are the guys actually trying to do this every day. They can tell you a lot of really good information about what they're missing. How are we doing this wrong? What's their frustration around security? Because again, at the end of the day, they want to have secure databases because they understand it's their job on the line if that database is hacked and all the data is lost. They want to make sure it's there so they can actually give you a lot of good information. Then working with IT security. So does IT security have any emphasis on databases? Most often the answer is no. So the answer is, okay, what tools do they have? What should you be working with IT security, and what should the DBAs be doing with IT security to get information like auditing into the centralized auditing platform for the organization? Next would be compliance and audit. So internal auditors tend to look at the applications and miss out on the databases. So is there a gap there? What input can they provide to this? And then finally, application owners can provide very good insight about, because they understand the application, they understand the sensitivity and the risk of the data. If someone goes in and starts changing data, typically the DBA would have no idea what the risk around that is. And the DBA may not even know if there's social security numbers, credit card numbers, other sensitive data in this. If someone goes in and actually brings down the application, that the manufacturing floor will actually stop working. The application owners have that information. So the key part of the risk assessment is that talking to the application owners and getting an understanding about what's truly happening with this database, with the application that is supported by this database, and what's the sensitivity of the data, what's the risk of the application being compromised, and things like that. So then you can go back and say, okay, yeah, we need to spend more time securing these accounts, because again, if any one of these people, maybe 50 or 100 people, have full access to social security numbers, is that acceptable in the organization? And as we go through that interview process, there's a number of different areas. And again, these are customized to each different person, but we're talking about, especially at an enterprise level, when you're doing enterprise risk assessment, is there an inventory? Is there a configuration standard? How does access management work? Access management is problematic at best in an Oracle database world. How do you do auditing? Most organizations don't do much around database auditing, because the result of that is you don't know who's connecting to the databases. Are databases being monitored in real time for intrusions? How is vulnerability management being done, especially around security patching on these large database platforms? And then finally, around protection of sensitive data, how is encryption being done? How is data masking being done? What are those policies? What tools are in place, and things like that? So again, these are the types of areas that we're asking through these interview process to get more information, especially around the process and procedures, because when we do the database security scans, we can get that information back. We can understand exactly what is happening, but in terms of how that's happening, what the processes are around, what are the procedures to actually make that happen, you really get by reviewing the policies and procedures, but you really get it when you do the interviews. You really get that understanding that how is access management done. I can read that policy document, but how is that actually being done in the field for a specific database? The DBAs can tell you that, oh yeah, no, I just did an email because that process doesn't include all the information I need, so they send me an email with the privileges. Is that acceptable? Is there a risk of that in the organization? How is that control actually working, and is there an effectiveness around that control? So the really key step here then is doing the database scanning. So I'm now getting the data from the database. And for a single database, it's very straightforward. I connect to that database, I gather the information. Potentially, I may be just giving SQL scripts to the DBA to actually do that for me. When we're talking about doing scanning around sampling in databases, it becomes much more complex, because now I have to actually figure out what databases I want. And most often, the database inventory, if one does exist, oftentimes it doesn't, is very lacking. It doesn't give me what I need to do to adequately scan the databases in terms of getting a good sampling. Because I want to know platform, I want to know version. Is this database got SOX data, GDPR data? Does it have social security numbers? Does it have credit card numbers? What team manages it? Is there multiple DBA teams? Because again, I want to sample from different DBA teams, because if I've got different Oracle teams, maybe one in Europe and one in the United States, they may have very different policies and procedures. They may be managing this completely differently. The way a custom application is done versus a package application is also very different. And this is the one point where we also now, I use the word sample. Again, we're sampling. And sampling has a certain connotation around randomness, that I'm actually just kind of picking out, if I've got 100 databases, potentially I'm randomly picking 10. When we do our sampling of databases, we are not doing that. We are cherry picking which databases we want to look at very specifically, versus based on these different attributes, and so we get a nice cross-representation. But we also want to pick the most important ones. So we're going to go after the largest databases typically. So the most important databases tend to be the largest. So if there's a database that's 2 gigabytes and there's a database that's 10 terabytes, that 10 terabyte database tends to be very much more important to the organization. That doesn't always hold true, but again, the larger the databases tend to be more important. So we tend to go through the inventory and spend some time and actually cherry pick out the databases, review that with the stakeholders during the interviews to say, we're looking at these databases. Is there a database that you think is more important than another one? And we tend to focus in on those much more than picking off that small little web application that's sitting in the corner that no one really cares about if it actually went down. We're picking the data warehouse, we're picking the ERP application, we're picking the order management application. Those are the ones we're picking. And we may take a few of those smaller applications and include them in the sample, but we're heavily weighting the sampling towards the largest databases, the data warehouses, those types of things. And the database scanning has actually two parts typically. I'm using a database scanning tool that's actually checking for specific security vulnerabilities, checking for misconfigurations, things like that. There's a number of tools out there. If you want a free one, is Oracle DBSat is a free tool from Oracle you can use for Oracle databases. For Integrigy, we actually use our product AppSentry on our own assessments. We wrote AppSentry because we needed a tool, and we actually now sell that. So those tools will give you the information about if there's an initialization parameter wrong, if there's a default password. What they won't do is do a very good job about giving you all the database permissions, giving you all the database accounts so you can go through and actually do detailed reviews of that. So you also need some sort of data retrieval tool. These may be SQL scripts, it may be a query tool. Integrigy uses a combination, again, of our AppSentry tool and an internal tool we call JInt Plus, which actually takes all the database, if you put in queries into it, and actually dumps the information into Excel workbooks for us, then we can do the offline analysis and actually work through it, do crosstabs, and do a very in-depth analysis around privileges, database accounts, things like that, so you can get an understanding of how the information is actually accessed and those types of things. And then finally, the last phase is actually the database risk assessment, the review and analysis. So you're taking all the inputs from the first three phases, now actually going through and trying to evaluate the effectiveness of the controls, looking at what data is in there, so what's the likelihood of compromising, developing the recommendations. So this goes through a number of different aspects in terms of looking at, you should be looking at the database security configuration against the standards, going through access management. How does access management work? How do database privileges work in the sensitive data access? So potentially even going through and finding, okay, this table and column has Social Security numbers. Who can access it? Why can they access it? Does the application access it? Are there ad hoc users accessing it? Are there database users with DBA privileges? With in Oracle, it'll be selecting a table privilege that can actually access that. How do I know it's those people accessing it? Are there generic accounts that can actually access that data? Those types of things. How is that sensitive data protected? Is it encrypted? Is it potentially masked when those ad hoc users go in? Is there auditing? So we then understand, looking at the audit trail, what's being captured in the audit trail. So very low level of analysis, going through all these different components to make sure it's operating effectively, the controls are in place, that there's not ways you can circumvent the controls, those types of things. And so the next few slides we'll now walk through, okay, that's the process of the risk assessment. What are some of the details? How do you actually go through and take this really large database, especially as like a data warehouse that may have thousands of users, and how do you break this up a little bit and try to get an understanding of what's actually happening? How to actually perform some of the key aspects of the risk assessment? So as part of the Integrigy methodology, one of the key things that we do is we segment accounts out, and we have a very in-depth understanding of how database accounts work and put those into categories. So we categorize it at a very high level, and we'll do this for, in the next few slides, I'll do this for Oracle. So we look at accounts as three key segments. There's the Oracle accounts. Those are delivered with an Oracle database. So most every Oracle database on the planet have these key accounts in them. Then there's a set of application accounts. These accounts are very specific to the application. And so these are generic accounts that the application owns. So in Oracle Business Suite, it's apps. In PeopleSoft, it's SysADM. In SAP, it's SAP R3. So these are the key application accounts. Then I also have ones that are like data owner accounts. I have interfaces connecting. So these are accounts that are not owned by a specific person. And then finally, I have user accounts. The user accounts should be named accounts. My DBAs should each have a named account. Each of the ad hoc users. So again, I may have accounts that are having to access the database. So Bob in HR may have a database account. Jane in General Ledger may have an account. So they can connect directly to the database and actually pull information back. They may have a query tool on their desktop, things like that. So the key is looking at these because each of these accounts have different aspects around security that are important in a number of different regards. The first would be access management. So when we're talking about access management, it's very important to understand there's many different parts of access management. And in an Oracle database, access management is a problem, is a massive problem. It is not handled well in many organizations because typically it's decentralized, it's in each database. You can hook up to Active Directory, you can manage the ad hoc accounts in Active Directory and things like that, but not many organizations do that. And so therefore, this is actually all controlled, decentralized, database by database, and typically managed by the DBAs unless you have like a database security administration team, which few organizations do. And so there's lots of different aspects in how you provision accounts. I won't go through this in detail, but again, provisioning, how do you actually handle things like password controls, how do you handle changes, and deprovisioning. Again, in an Oracle database, if I have account termination, the DBA is responsible for doing that account termination. So that becomes a very critical control. And if it's decentralized database by database, is that being handled appropriately in the organization? And so this is an example now of I take that and now I map that to my different types of accounts. And this is very much an example. And in this example, this organization was using Active Directory to control their database accounts. But again, in Oracle, that doesn't happen very often. And all those different controls on the last slide, we've now mapped out, or we mapped out in the organization how it should be being handled, and is that being handled appropriately? So we then reviewed each of these to say, okay, for passwords, well, you've got this generic sys account in every Oracle database, which is the root of the database, very, very highly privileged. Who accesses that account? Where's the password stored? How do you know that's actually being done? Those types of things. So it's very important on how each of these controls work because you can see these are standard processes across access management, but for the sys account, the way these processes work is different than for the DBA account. It's different for the application account. So each of these different categories is different. So my Oracle accounts are handled differently than the application accounts are handled differently than the ad hoc user accounts for like an Oracle database in terms of access management. So now am I talking about access management? I'm talking about just authorization. I may be doing authorization 2 or 3 different ways. I may be controlling passwords 2 or 3 different ways. And each of those processes may have weaknesses. On interface accounts, typically like an interface account, the password is the DBA gets a request to create the account. He creates the account, sets a password, and typically emails that password to a developer. And the developer sets it up in the interface on an application somewhere else in the organization. Well, that developer now has that password. Can that developer access that account whenever they want? Absolutely. There's no controls around that unless you built that in. Is that a control weakness? Potentially, absolutely, especially if that interface isn't designed well and that interface account may have way too many privileges. So these are the kind of types of issues that until you get into that process and understand it, and then when you're actually thinking about it from these different types of accounts, you would never actually see it. So it's very important that you get down to this level of detail to understand that there's different processes for different application accounts. So we take another example here, and we actually now look at it based on access and privileges, taking these same accounts and now try to go through, and this is, I kind of summarize this at a very high level so it's a little bit more understandable, but looking at access, privileges, and auditing across these different types of accounts, again, how I'm doing access, well, I may be doing it really well for my named accounts because they may be set up in Active Directory, or actually we're doing that process well, but how am I controlling these application accounts? These are generic accounts. Where's the password? Who's got control of the password? How do I know who's accessing it? Do I have auditing turned on? Do these interactive accounts have too many privileges? Do my interface accounts have too many privileges? Well, my interface account, if it's bringing in orders, it should only have access to orders. In a large ERP system, they often give too many privileges, so your interface that loads in orders often has full access to your HR system in a large ERP because it's all highly integrated. So that's why you have to think through a process like this and say, okay, here's these different types of accounts with different access. How do I actually handle privileges in that? How do I handle auditing in that. My audit requirements based on account may be different, although for databases, my auditing may not be able to be segmented out by these types of accounts. So when you're doing the risk assessment, this is the kind of level of detail you need to get into and some of the things you need to be thinking about. And this is what's often missed is because, again, oh, we did a database security scan against it, everything's fine. But you're missing out that, well, you've got 10 accounts with DBAs, and do I need 10 DBAs in every single database? Are those DBAs still here? Were they third-party contractors who are no longer gone and somebody never went through every single database to remove their account? So there's lots of gaps, lots of potential risks in each of the databases that need to be addressed. And by just doing a simple database security scan doesn't give you that information. That's why going through a detailed methodology, and I've tried to lay out as much as possible here to look at and think about ways to look at this, what needs to be looked at and why it needs to be looked at. So that was a very high level, going through kind of 8 key components that we look at, especially during security assessments for databases when we do it in Integrigy, and kind of gives you an idea when you're doing this at some of the databases within your organization, some of the things you need to be thinking about, some of the things that you should be pulling, information you're gathering, people you're talking to, and ways to look at the database security from a different perspective. I will turn it back to Phil and see if there's any questions.
Thank you, Steve. Yes, there are some questions. How does the assessment change for databases in the Oracle Cloud or Amazon Web Services?
That's actually a very good question. So again, a lot of organizations are now moving their databases up into the cloud. So they're being hosted at organizations like Oracle, Amazon Web Services, Rackspace. There's many different organizations out there that provide cloud database hosting services. It doesn't change much. When we actually went through this whole presentation, we didn't talk about infrastructure operating systems. And most of the database services offered are giving you a database. You're the DBA. Sometimes they'll also give you DBA services around it, but you're still installing the application. You're still controlling those privileges. You're still controlling the access. You're providing the auditing. That's a very different model than when you talk about like a service like Salesforce. You don't have access to the Salesforce database. But most cloud hosting for databases, you're just getting a database and they're giving you full access to it, and you're providing the DBA services around that. So you're creating accounts, you're installing the application, you're changing privileges. So this risk assessment doesn't change much. It may add some other things around, like who else might have the access to the data within that cloud hosting provider. So it's more expanding it, but the core risk assessment really stays exactly the same.
Next question. Does the methodology also work on Microsoft SQL Server, IBM DB2, and MySQL?
Yeah, so we do most of our work around Oracle databases. We also do a lot on other databases, but again, this methodology works for really all of the database platforms. There's some tweaks and some interesting things that will change between them. Things like on SQL Server is very easy to hook up to Active Directory. So very seldom do you see a SQL Server that's not hooked up to an Active Directory for the ad hoc users. But again, the service accounts are typically still, and the application accounts are still stored locally in each database. But also what you see on the SQL Server world is they tend to be scattered more. The DBAs tend to be more Windows administrators in some cases. So you may have a core SQL Server group, but actually if you do a scan within your organization looking for SQL Server databases, they are scattered to the wind. They tend to be more departmental. So you may have just someone working in a single department managing a couple of SQL servers, where then you also have a centralized SQL Server team. So for Oracle databases, we tend not to do a lot of work about scanning the network looking for SQL Server, looking for Oracle databases, but absolutely we will do a lot of work around scanning for SQL Server databases. DB2, Teradata, Sybase tend to be a smaller fraction. They tend to be very well controlled because, again, there's not a lot of them. They tend to have like a few DB2 clusters. They tend to have one or two Teradata clusters within an organization that tends to have a smaller DBA team. It tends to be a little bit more controlled, and they tend to be installed at the same time. So very seldom you see that, yeah, we've been running Teradata for 10 years and we installed 5 applications on it. It tends to be one key application, maybe 2 applications, and it tends to be a little bit more tighter and compact So therefore, to me, this assessment is usually easier versus having 10 or 15 disparate applications running. But again, the methodology is very similar, the same. It's just kind of the slight flavors of it. You'll see some idiosyncrasies across each platform, but nothing generally would change from what we walked through today.
Next question. Please talk more about the risk around database account termination.
Very good question. This is one area that we see and is almost always a finding in our database security assessments when we do at organizations, is around this database account termination issue. So again, in a large Oracle database environment, let's say you've got 100 Oracle databases, unless you've hooked it up to Active Directory, which is the minority of Oracle customers, typically the security is handled in each database. So if I've got 100 databases, I've got security handled 100 different ways because each database is managing security on its own. And typically in that environment, the DBA would be creating the database accounts. You don't have some central security team unless you work for a large financial institution. So the DBA has created the account, so Jane gets an account in the database, and she may have 3 different accounts in 3 different databases. So each DBA went in and created Jane an account in each database. Jane leaves the organization. How many organizations out there have a process that the DBAs are notified of employee terminations? Very seldom, if any. Therefore, Jane's account is now active in 3 databases, and Jane is no longer with the organization. So recently we did a large assessment because access management was an issue for an organization. They ended up having 250,000 database accounts across all their databases. Those are accounts per database, and they only had 30,000 employees, but they had 250,000 database accounts. As we found out, the number was something around 70% of those database accounts were no longer active when we got down to the ad hoc user. So again, we took out all the Oracle accounts, all the service accounts, all the application accounts, and got down to named users. And we went through those named users. And again, the naming standard wasn't consistent. And 70% of those accounts were for no longer active employees, even though the accounts were active in every single database. So that is a significant problem. So when you're looking at a database risk assessment, look at the list of database users, categorize it out to say, okay, these are named accounts, and hopefully there's a consistent naming standard, then that maps potentially to Active Directory or your standard naming convention within the organization. And then you can get a terminated user list, or just start sampling them and going to your employee directory and picking off name by name and trying to figure out how that works. We just completed a recent security assessment on a large number of databases. We did about 50 databases, as I remember, and they did not have a consistent naming standard. And so we had B. Smith. They used first letter, last name. And so in these databases, we found B. Smith for Bob Smith in a bunch of different databases. Unfortunately, we could not map back Bob Smith to actually be the named user. And by the way, there was 12 Bob Smiths within the company. And so we had no idea who Bob Smith was and how to map the Bob Smith. And oh, by the way, then there was a bunch of terminated Bob Smiths also. So we had no idea on how to map that because the naming standard for database accounts didn't map to the organizational standard. And like in the Oracle database, there's no other field. There's no field that you can put employee ID in for a database account. So again, we had no idea if those accounts should be terminated, who they actually map to, things like that. So account management and access management around Oracle databases, especially around terminated accounts, is hugely problematic. Even around just normal accounts, just to manage them and maintain them can be an issue too.
Okay, I think that wraps this up for the day, Steve. Thank you very much. And thanks everybody for attending this afternoon. And again, please put on your calendar for Thursday, the 15th of October will be our next e-session. The title of that is Implementing a Two-Factor Authentication for the Oracle E-Business Suite. So put on your calendar and we'll see you then. So have a great rest of the week.